Okay, good morning everyone. Week 4. We have done already almost a month. I hope you have had a great weekend and you're ready to continue our fun with Python. As one of you has mentioned, things are just starting to get fun, it depends on your definition of fun, but from last week, we started working with conditional statements, for loops, and these are very core programming concepts. And so if you have any comments, questions from last week's, now is a good time to put them here so we can go through it. But otherwise, we will start. We have a number of topics that we will be covering today, and I will show you an overview of what we are going to talk about soon. Yeah, about videos, I got the comment from a few students that the volume of recording wasn't that good. I tried to turn it up now. Hopefully it works, especially for those who will be watching this later. I hope the sound is better. Okay, if there are no questions, let's continue. And things are going to be even more interesting this week. We are going to work with functions. We will learn how to write the scripts, work with different kinds of modules. And so let's open CSC Noppe if we haven't done so already. I have already pulled the latest changes. So after pulling the changes, you should have L4, lesson 4. Let's open that. Lesson overview. We are going to learn about functions. So this is one of the core topics in programming, any programming language, and I will shortly tell you what we mean by functions in Python. We will briefly talk about modules. We have already seen that in first week. Remember when we were trying to do some basic math like a square root and calculating sinus. We imported one module to do that. So we continue talking about those and see what they mean and what we can do with them. We also talk about the scripts which are related to modules and functions. We will see how we can produce the scripts. We also have one extra part today. We will briefly talk about AI and large language models, specifically focusing on ChatGPT and what that could potentially mean for you as a programmer and how we can use it in the right way. So we will briefly talk about that. We will have a break as usual somewhere in the middle. So the learning goals today, we will explain how functions are used and what are their benefits. So why should you bother creating functions and how can they help you with your workflow. We will describe the pros and cons of using AI and large language models in generating code. We will learn how to create our own functions to calculate an output value based on input. Save functions to script file for future use. So that's what we're going to learn today. Let's go back to Noppe and open folder 4, L4. I start with functions. Okay, so what are functions? The same concept exists in almost every programming language. A function is a block of organized, reusable code that you can that can make your programs more effective, easier to read, and simple to manage. And these are things that we are trying to do with programming. Like I say almost every week, one of the main motivations for us, we are not computer scientists, most of us at least, so one of the main motivations for us is to automate some of our processes and in the long run just make our lives easier as professionals. So functions are one of those core concepts and tools that are going to help you achieve that. So before we go through the technical stuff, let me give you simple examples of what we try to achieve with a function. Imagine you're cooking something and you have come up with a very good recipe how to make a food in a certain way, or you have done a lot of Googling and you have found a way how to make your favorite food in the best way possible. So imagine you want to probably make that food every now and then. It's your favorite food. You're going to make it twice a month or something. So do you really want to go through the trouble of finding that recipe every time you cook? Sometimes you might do that. If you're lazy to save the page or write down how we made the food, you might just do that, and then probably you will regret it later because it will be hard. You have to redo basically everything. So it's the same with functions. Or imagine in a case that you have a very interesting story, and everyone who sees you wants to tell you, hear about that story. For example, you have traveled somewhere, you have had great adventures, and you are going to see your friends, and everyone is going to ask you about that trip. At some point, you might get tired of it and just wish that, okay, I wish I could just record myself, and whoever asks me about that trip, I could play the recording so they could listen to it. So this is what we try to do with a function. You are performing a task, or you're calculating something, and you're going to do this many times probably. And do you want to copy and paste the code every time? Probably not. So with functions, you just take a very good step toward automating that process and making your code reusable. Yeah, so functions are a good way of so you don't repeat yourself. There are many functions that are built in Python, and we have seen that. For example, every week, 100 times, we are using this print function. So developers of Python have defined this function that prints out the output to your screen. So they have written the code. Well, of course, you can imagine, to make a computer understand to do that, they have provided instructions. Imagine if you had to provide those instructions every time you wanted to print out something to the screen. That would have been annoying. So they have made that function, you use it, and your life gets easier. So you might want to do the same thing. You probably want to do the same thing with your own codes. So let's start by looking at the anatomy of a function, and then we will practice with it and see how we can create and use functions. So one of the examples that are quite intuitive and we use quite a lot in this course is conversion between different temperature units. So today we are also going to work with many examples, working with different units, going from Celsius to Fahrenheit, Kelvin, and even another less known temperature unit. So this is the structure of a function. So how do we define a function? There's a keyword called def, which is short for define. So this tells Python that you're going to create a function. So this is the definition level. You're not using it yet. So this is how we define a function. And here is the name of the function. So you can just put anything. So the same rules when we were trying to create a variable names apply here. So you cannot use words that are reserved by Python. You cannot put a space there. So the same naming rules apply here. You give it a name that is understandable, intuitive, not overly long. And then parameters. So what do you, very often, it's not a must, but very often, depending on what you're doing, you provide an input to your function. The function uses that input to produce the output. So in case of a temperature conversion tool, well, you're converting something, so you have an input. So you provide the temperature in Celsius, so that's your input. So you have parameter, it can be one or more than one. And then you have the colon, so you have seen this before, for example, when we were writing if statements or for loops. So it tells Python that, okay, I'm starting a block of code here, what happens in my function. So you can do a lot of things in between. You can calculate things, you can print things, you can do different things. But your function usually ends with return. So return is another reserved word in Python. So it tells Python what the function should return to the user. And we will see that. So the return can be some calculation you're doing, it can be some variable, and sometimes we don't even return anything. We just perform a task. For example, you write something to the database without showing anything. So this is the overall structure of a function in Python. So it's very intuitive, but let's start writing our own function. So as I said, you tell Python, do you also hear the echo? Like the microphone is a bit annoying. Yeah. try to fix this. Okay, I guess it's better now. Yep. Okay, so let's start defining our function. I'm going to name it same as in the screenshot, Celsius to Fahrenheit. So like I said, this follows the same rules or guidelines as naming variables. Go with a name that is like a name that makes sense, easy to read, not overly long. So in this case, I'm going with Celsius to Fahrenheit and separating the words with underscore. Here you provide the input, so I want to use get a temperature as the input. So here, it doesn't matter what you name it, this will be the name of the variable that you can use inside the function. And we will see what I mean by that very soon. So I'm going to calculate something. Yeah, so you can see in this screenshot, you can just do the calculation right here in front of return, and you return the value. But I'm going to store it in a variable and then return it. So I'm going to create a new variable called ftemp, so temperature in Fahrenheit. And we already might remember this is the way to convert Celsius to Fahrenheit. So 9 divided by 5 times temp plus 32. So we have done this several times during the last weeks. You convert the temperature. So this was temp, so E. Yeah, so remember, you can see that, okay, the person who is using your function is going to provide an input. That input will be written inside this variable. So this is a variable, same as what we have used every week, except that this variable is only accessible inside the function. So I'm going to use this variable, which is temperature in Celsius, let's say 25, and then I'm going to do some calculation, store it under f_temp. Then one important thing is to return the value, otherwise your function will not return anything. And there's a keyword for that, return. And what I'm going to return is the ftemp that I calculated. So like I said, you could have skipped this step and just, like you see in the picture, you could have just done the calculation right in front of return. But I personally like this better. So let's run this. So as you can see, apparently nothing happens, but something happened. You defined the function, so Python knows that this function exists, so it's accessible to you. But you don't get any output because you haven't calculated anything yet. Okay, so this is how you create functions. It's a very simple function, but they can be more complicated. They very often have more lines, more things are happening inside the function. But once you do it, now this function is defined, and now we are going to see how we can call the function. So calling a function or using a function. How do we do that? You just use the name of the function that you define. So it's very simple. And if it needs inputs, then you provide the input. So I'm going to calculate the freezing point of water in Fahrenheit. So I know it in Celsius. It's at 0 degrees, but I'm not sure what it would be at Fahrenheit. So that's why I'm going to use my function to do the conversion. So this is the name of your function, the one we just defined. So Celsius to Fahrenheit. So without calculating things, I'm just going to call the function using its name, provide the input, which is 0. You can try it with different values. And just run the function. So now the calculation is done and the value is stored on the freezing point. To make sure this was done properly, I'm going to print an F string, and I'm going to write something, the freezing point of water in Fahrenheit is, and then I'm going to just insert the variable I created. So it was freezing underscore point. So you see the calculation was done. I didn't repeat the code. I didn't repeat the calculation formula. I just called the function, provided the input, and you can see that in Fahrenheit is 32 degrees. So the function worked well. So it's very simple. Remember, you define the function, you run the cell in which you have defined the function, of course. That's easy to forget, especially if you're working in Jupyter Lab. And then the function is available to you. So like I said, one of the greatest things, the reason why you write a function is that you want to repeat that process without repeating the code. So let's just repeat this process. And I want to see what is the boiling temperature of water in Fahrenheit. So I'm going to write another F string. And there I'm going to write the boiling point of water in Fahrenheit is. So we could have calculated the value beforehand, but now I'm going to just do it on the fly. So I just use my function, Celsius to Fahrenheit, and I'm going to provide the input. So I want to see what is 100 degrees Celsius in Fahrenheit. And you can see it's 212 degrees, the boiling point of water. So I just reuse the function. So hopefully you get the point now that, yeah, here it was a one-line code, simple conversion, but imagine if you're doing something more sophisticated, then you can just reuse that block of code. Okay, let's keep on practicing with functions, and now we are going to create a new function doing another kind of temperature conversion. So now that we know how to create a function to convert degrees Celsius to Fahrenheit, let's create another function called kelvins to Celsius. And as you can guess from the name, this will convert temperatures from kelvins to Celsius. So this is very similar. Let's define the function. I give it an understandable name, so kelvins to Celsius, kelvins underscore 2 underscore Celsius. Again, you need an input. You can choose whatever name you want. I'm going to call it temp Kelvin. Remember to put the colon. And again, similar to for loop, if statements, you know that the Python is using that indentation to know that this is inside the function. So I'm going to return something, and that's the, and this is how you convert kelvins to Celsius. So it's temp kelvins minus 273.15. So make sure to run the cell so the function is defined. Now let's use our function. So I'm going to calculate absolute zero in Celsius. So I'm going to store it under absolute zero. And I'm going to use my freshly defined function to do the conversion. So kelvins to Celsius. And as input, I'm providing 0. So why am I writing the name? You don't have to, but it's a good practice. Well, you really don't have to, but it depends on the function. So by default, well, here you have only one, so there is little room for confusion. But imagine if your function is going to take several inputs, which is often the case if you're using a more complicated function from a library. It takes a lot of, like several inputs. So it reads it in the same order as it is defined. So imagine if our function in the definition stage had several inputs, like temp. Imagine if you had made a function that can do all the conversions at once. So it takes temperature kelvins as input, Celsius as input, and the type of conversion as input. So when you're providing the inputs, it should be in the same order. But by providing the name, then you make sure that it goes to the right place. Yeah, so you will see that. In this case, we didn't need to do that, but this is something you will see sometimes. So let's run this. Now absolute zero should be calculated in Celsius. And now I'm going to print the output as usual to see that if that's the case. So absolute zero in Celsius is, and then I'm going to put the variable absolute underscore zero. And you can see absolute zero in Celsius is minus 273.15. Okay, so let's practice one more thing. Well, most of us know Newton, but not for temperature units, for other things he has done in physics, but what he's less known for is a scale of measuring temperatures that he had developed, so it's very similar to Celsius. So the 0 degrees in Newton is the freezing point of water, but the boiling point was set to 33. Yeah, so the conversion is very simple. This is a formula. The temperature in Newton is temperature in Celsius times 0.33. Your task here is to create a function called Celsius to Newton that has one parameter, is the temperature Celsius, and you convert it to Newton. And you return that. So let's take a couple of minutes and do that, then we do it together. So define the function and also try to use it, see if it works without error. So how many of you managed to define the function and use it without error? Just raise your hands. Yeah. How many of you are still working on it? Okay, so let's continue. while you're creating your function, you can try different things, change names, change variable names to see how things work. Okay, so I start defining the function here. So define, I'm going to name it Celsius underscore 2 Newton. I'm going to name the input temp Celsius. As we know, the conversion is fairly simple. We just multiply temp Celsius by 0.33. That's it. So we define a function and it's ready to be used. Okay, so now we know how to use functions, and we are going to use them quite a lot. Like from next week on, things get still even more serious, and by serious I don't necessarily mean difficult, but more interesting. We are going to use a library called pandas for data analysis, so we'll start data analysis from next week, and you will see that functions can really help you conducting different kinds of tasks, calculations when you're working with larger data files. Yeah, so now we saw how we can define functions, very simple functions. Another thing that you can do, and sometimes you need to do, is functions that benefit from other existing functions. So now we want to write a function that converts temperature from kelvins to Fahrenheit. Of course, you can just go do the calculation straightly, but remember that we already have two functions that can help us achieve that. We have already made a function that can convert kelvins to Celsius. We just did it a few minutes ago. And we also calculated a function that takes Celsius to Fahrenheit. So we can do the same thing here. Use those two functions in our new function without repeating those conversions. So let's see how that one works. I'm going to create a new function called kelvins to Fahrenheit. Kelvins to Fahrenheit. And it's going to take one input. You can name it what you want. I'm going to name it temp underscore kelvins. So I'm going to use those two functions that we have previously created. So first I bring my temp kelvins to Celsius and I store it in a variable named temp underscore Celsius. And this is the function that we had previously defined. So it was called kelvins underscore 2 underscore Celsius. What's the input? Of course, the input we got from function. Okay, so at this step, I have my temperature in Celsius. And remember, we still have another function we defined earlier that takes temperature from Celsius to Fahrenheit. So I will store this new value under a new variable called temp Fahrenheit. Celsius underscore 2 underscore far. This was the name of the function we had defined. And remember, now we use this one as the input. Because we got this as input from the user. We took it, we converted it to Celsius, and now from Celsius we want to take it to Fahrenheit. And once we do that, we want to return the converted value to the user. So let's just run the cell. Now the function should be available to us. Now go ahead and use the function for converting any temperature that you want. I will also do it here. I will start by testing it with absolute zero. So I want to know what absolute zero is in Fahrenheit. We already know what it is in Celsius. So absolute zero Fahrenheit. I'm going to use this new function, kelvins to Fahrenheit, to do my conversion. Temp kelvins 0. Like I said, you don't have to specify the name of parameter, but it can be good with more complicated functions, with more inputs. Let's run this. And as usual, let's print an F string. So absolute 0 in Fahrenheit is, then I'm going to just put what I just calculated. I will just copy the name. Yeah, so I ran the cell and it says that absolute 0 in Fahrenheit is minus 459. So is it all clear? Do we already know how to define and use functions? Yeah, so very intuitive. Now let's look a bit more closely at function parameters and return values. So we have been already using them. You get inputs. So far we have worked with temperatures and you saw that you can return an output. But let's take a closer look at how this works. So one thing to remember is that functions do not necessarily return anything. So sometimes you're calculating something like this, you're converting something, you print it out, or you use it again in somewhere, so it returns a value. Sometimes, like I said, they conduct a task. So imagine you're calculating something and you're writing it to your database. So you don't need to return anything. You just access the database, the function accesses the database, writes it there, and that's it. You don't get anything as output. So that's why the return line is not necessary. So this is, here you can see a function that doesn't return anything. So it's a function that prints kelvins to Celsius, so it does the conversion and prints it. So it's performing a task without returning anything. So when you run the function, it just prints it. It doesn't return you the value. So these are also functions that you may use. So let's just run this and test it to see what I mean. So I'm going to test it with 0 degrees. So print kelvins to Celsius. That's a long name we are using here. And I tried with 0. And you can see the output. So you're not really returning anything. The value is not stored anything. It's just when you use the function, this line of code that is inside the function is run. So it just prints. So the print is happening in the function without returning anything. So for print, in case of printing, it's not maybe the best thing because you may want to have the value accessible, store it in a variable, then print it outside the function. But like I said, there are many tasks that do not require returning any value. They just perform something. Like, I don't know, for example, you do some calculation, you send an email to the user, or you're using this in a website and you send an email. So the email doesn't have an output for you, it's just a task that is done. The website sends an email to the user. So you can think of many tasks that functions can run without returning a tangible output. Okay, so let's try one thing. You might be wondering, okay, what would happen? Now that my function doesn't have a return statement, what happens if you do something like this? So if I try to store the output of this function, I'm going to copy this. Just print kelvins to Celsius for 0. What if I try to store this in a variable? And I'm going to print the output to see what I get. And if you run this, you can see that you get none. So you can see that this is printed because this was part of the function, so it's getting printed from here. But nothing is stored here. So output is none. And the reason is that your function doesn't have return, so it's not returning anything. So if nothing is returned, nothing is stored in output. So you get none. So if the function doesn't have return, you get none as the output. It does what it has to do, but it doesn't return anything. So remember that. Yeah, so that was about return. So remember that you may not necessarily have return. Let's talk about parameters. Parameters, so far we have worked with functions that take only one parameter, very simple conversions, but you can also have functions that are a bit more complicated, like what we have here, and it can take several inputs. So here you have a conversion tool that can do multiple conversions, so instead of having several functions, you just have one smarter, more comprehensive function, and for that to work, you need more inputs. So here we have a new function called temp in comfort range, which takes the temperature in degrees Celsius as the input. It converts the temperature to degrees Fahrenheit. It checks to see whether the converted temperature is within the specified temperature range. And returns a Boolean value resulting from the comparison. So similar to what we have done last week. So let's look more closely to the function. So that's the name, Celsius. So temperature Fahrenheit ideal. So what temperature do you consider as ideal temperature? Yeah, so you do the calculations here, you calculate the range, and then you have a Boolean statement. So you have a conditional statement, and it returns a Boolean value. So let's just run this so we don't have to type anything. And I'm going to try it with these inputs, so temp underscore in comfort range. And these are my inputs. So 21 is the temperature in Celsius I'm using. For temperature Fahrenheit, I'm going to use 68. And for the range, I'm going to use 5. So remember what I said earlier. When you have multiple inputs, they are loaded to the variables directly. So the order matters here. So when you use this 21 is written here to temp Celsius. 68 is written here. 5 is written as the value here. And why do I have the values here as well? So this is a default value. So if you want your function to work, if the user of your code, your function, does not want to change the ideal temperature or the range, if they don't provide those values, the function will just go with the default values. So if you provide a number, a value, when you're defining the function, this will be used as default unless the user provides another value. So in this case, they are the same values, but if I had provided another value like 6, 6 would have been used. So 5 is the default. Yep, so here the order matters. If you are unsure of the order, then you should provide the name of the variables. So remember earlier we've used these. For example, you can specifically say that temperature Fahrenheit range is 5. In this case, the order is not that important because you're exactly pointing to the right variable. But otherwise, make sure it's in the right order. Is it clear? So we can have many inputs. The order matters. If you're unsure of the order, for example, for those of you, some of you who might be using, continuing with doing GIS with this, you will see that there are a lot of functions that take a lot of inputs. So very often it's just easier to use the name of parameter to make sure you're not making a mistake. Yeah, but let's run the function with this, and you get true. So the statement, the condition we had here was true, and it's returning true as the output. So as we can see, 21 degrees Celsius would also be considered a comfortable temperature in the US. Of course, we're working in Fahrenheit. However, you may notice that we have multiple parameters. It's easy to confuse them. And like I said, you can provide the name of the parameter specifically to avoid confusion. So let's do the same thing again. Temp in comfort range. Temp ideal 68, temp Celsius 21, and for the range I'm using 5, temp var underscore range equals 5. So I get the same output, but since I've specifically named the parameters, even if I get the orders wrong, they will end up in the right place, and my calculation will work fine. And that leads us to the next thing, which is required or optional parameters. So I already briefly talked about this, but let's see what I mean in practice. So I'm going to use the same function again, temp in comfort range. And I'm going to try 19 degrees to see if it is within the comfortable range or not. And if I run this, you see it's true. So my function was defined to work with 3 inputs, but I only provided 1 input. So do you know why I didn't get an error? I already mentioned this briefly. You don't have to say, just raise your hand if you have some guess why I don't get an error. Okay, so some of you know. And the reason is that I have provided default values. So if I miss the parameter, if I don't say anything, then it just goes with the input, with the default value. If I did not have these default values here, I would have gotten an error because the function is confused. It needs 3 inputs, and if you give it just 1 or 2, it's going to throw you an error. So if there are default values, it goes with the default, unless you overwrite them. So let's try this, and this time we go without any inputs. I'm just going to paste this here, but I delete the input. And you see, this time I get an error that this function is missing 1 required positional argument. So it's telling that, okay, temp Celsius, that first parameter was mandatory. So you have to have it because there is no default value for it. So this can happen if you are not providing enough inputs for your function. This is the error you get. You get a type error.
So this means that while we are defining the function, we are also defining the variable at the same time.
Yeah, the variable that will be used inside the function. And we are going to talk about this more now. Yeah. Okay, so that's the thing. Again, back to the examples with like GIS, like very often functions have a lot of different possible inputs, but also they have a lot of defaults. For example, you're doing some calculation, you're getting distance between these two points in GIS, and you can have different considerations of the coordinate systems, or do you want it on the curve of the Earth, or do you want it on a flat Euclidean surface? So the function might have some assumptions, so if you don't say anything, it might just go with Euclidean distance, but you have the option of saying that, okay, calculate distance this way. So you see a lot of those things when you're using functions coming from libraries. But we will get back to that later. Let's look at one more thing. functions with multiple returns. We already saw that functions can have no output or a single output. We haven't had the situation where it returns multiple values. And that's possible. You can do that as well. So here we have a function, temperature, similar function, same function we are defining again that tells you whether the temperature is within the comfort range or not. But this time it's returning two values. It's returning the temp in range and it's returning the temperature in Fahrenheit. So this is how you return multiple values. So you just put a comma in between. So if you wanted to return more variables, you could have just continued. So there's no limit how many you want to return. But let's see how this works in practice. So I'm going to run this function now that is redefined. Remember to rerun this, otherwise you will use the earlier version of it. So temp in comfort range, and I'm going to try it for the input 27 degrees. So now when I run the code, I get two outputs. So you can see it doesn't only say false or true, it also returns the temperature in Fahrenheit. And now you're seeing a new data structure in Python, and this is called a tuple. I had mentioned this in week 2 when we were working with lists. Remember, we were talking about lists, and I said that there are different types of collection data types in Python. Lists we are very well familiar with already. Tuples is another kind. So they're very similar to lists. One difference is that in how they look. So with lists, we had those square brackets. In tuples, one sign that this is a tuple is that we have this parenthesis. So this is telling me it's a tuple. So, and there are a number of differences in how efficient they are, how they work, but one of the main differences is that tuples are not mutable. So you cannot change tuples. So if you have to overwrite the whole thing. You cannot append, you cannot update a value, you cannot delete a value. And it works nicely for certain things. For example, like I mentioned in week 2, when working with geographic data, you don't want to mess up with your x and y coordinates. The x and y coordinates are defined as tuples, so you cannot mess them up. Okay, so now let's look at these tuples a bit more closely. So I'm going to do the same thing now, but to test the output, I'm going to store it in a variable. And this is the name of the variable I'm going to use. So comfort range output. And I'm going to use my function with the same value. And here I'm going to test the type of the data to make sure that it is actually a tuple. And it's going to tell you it's the tuple. So, like I said, it's a new data type that we are seeing. So we won't be working with tuples except when we see it as outputs of functions with multiple values. But like I said, some of you who will continue working with GIS with Python, you will see tuples more. Yeah, so how do you access the values? So now it's returning you two values. As I said, tuples are very similar to lists, so you can access the values individually in a similar way. So I'm going to print the values individually. So remember that I have gotten a tuple that is stored here, and I can access the values inside the tuple using their index value. So very similar to lists. So to get the first item, I'm going to access index 0. And I'm going to do the same thing for the second item stored at index 1. Okay, I have a typo. Yeah, so very often you will see functions that return you many values, but then remember that the output will be a tuple, and you can access the values individually using their index value, similar to lists, like this. Then you can use it in your work. what you see very often when working with functions that you're very familiar with and you know what they return is that you can just, you know it's a tuple, you know the output will be a tuple with two values. So one way of accessing the individual values is using the index. Another way is like this. So I'm already going to fetch the outputs like this. So I know that two values will be returned. The first one will be the in range. The second one will be the Fahrenheit temperature. Then I'm going to run my function, temp in comfort range 27. So what happens now? The output is a tuple. The index 0 goes to this. In range is stored in this variable. Index 1 is stored in this variable. So I don't have to repeat this step like explicitly. So let's see what I have in my in range, the variable I just created. So the first value went there, which was Boolean. And if you test it for the other one, it should be a float because it's the temperature. So Fahrenheit temperature. And you can see it's a float. So it directly loads the values to the variable. So your code gets a bit shorter. Okay, about variables inside function, we already had a question about this. Now we take a bit closer look into how variables work inside a function. Yeah, let's try to figure this out. Let's see how it works in practice before I start explaining. So let's define a new function, kelvins to Celsius. It takes temperature kelvins as the input. It does the conversion and stores it in temperature Celsius. You have done something similar before, so if you don't feel like typing, you can also copy and paste. So temp underscore kelvins minus 273.15. And of course we want to return the value, which is stored in temp Celsius. Okay, so now with this function we want to test a few things to see how variables behave. So let me try one thing. So temp Kelvin. So now I ran this cell, so this function should be defined. Now if I try to get the output for kelvins, or just check this variable, if I run this, it says name temp kelvins is not defined. So even if the variable is defined here, we are getting this error. Let's try it for this other variable. So we have defined a variable here, temp Celsius. I'm going to see what happens if I try to access that one. I get the same error. It says name temp Celsius is not defined. So what is happening is that with functions, you have a different namespace. So if you define a variable inside a function, it's not accessible outside the function. So these are inside this function, so temp kelvins and temp Celsius. So if I try to access them outside, Python doesn't know they exist. So Python has different namespace. We have a global namespace, the variables you have defined outside the function, and you can use them very, very in your code. But if you have specifically defined a variable inside the function, it's only accessible inside that namespace. Outside, it's not recognized. So what do you do if you need it? Well, you have to return it as the output. When you return it as output, you can use it in your code, but it's not automatically accessible. So remember, there is a different namespace for functions. So each function has its own namespace. So that's a very common mistake people make when they are new to Python and programming functions, because this is handled a bit differently in different programming languages. Okay. So you might be thinking that we have not yet called the function, which is not true. That won't affect it, actually. But just to be sure, let's test it. So kelvins to Celsius temp kelvins equals 293.15. I want to see if I run my code, if I run my function, will it make those variables accessible? No. So even if you use the function, the code is run, but as I said, the namespaces are separate, so still it's not defined. So if you need to also access a variable inside your function, you have to provide it as a parameter. That's why we have those parameters. So you provide it as an input, and if you want to have access to it outside, then you return it as a new value. Okay, so let's still try a couple of things. So you might be wondering why this is important. It is actually quite a good feature of Python, because if you're using a lot of functions, or if you're importing functions from other libraries, they might have used all kinds of variables. And imagine if it would overwrite your code. So in your code, you might have temp Celsius, then you're using some library somewhere that is working with temperatures, and the same word temp underscore Celsius is used. Imagine it's just going to overwrite your variable. So it leads to confusion. So it's actually a very good feature of Python. Okay, so let's continue exploring this. So I'm going to define a function, def kelvins to Celsius 2. So I'm and it takes the temperature as input. And it's going to do the conversion. So let's define the function. So now we pass in a new input to our function. So I'm going to do this, run this function with the. Okay, so temperature is 303.15. Then I'm going to use this function. I just copy the name because it's a bit long. And I'm going to do the conversion. So it needs one input, temperature, and for input I'm using the same variable. So I'm using this 303. So what do I get as output? I get 30. And now let's try this value. Okay, so what I'm trying to tell you here is that, okay, I had a variable in my global space, like outside the function, named temperature. And it was holding a value of 303. Then I changed the value of this variable inside the function. So I had another similar variable called temperature, but it was in the name, in the function. So when I ran the function, the value changed to 30. But when I try to access it again, it's 303. Because if you have a variable, like I said, they're separate. So if you have a temperature outside, then you use the same word, the same name for a variable inside the function. You update the value. It will not update your global variables. So these are separate things. So this is just to show you. If you change the value inside the function, it hasn't changed globally. They are different namespaces. And like I said, if you really want to update it, then you have to get it as return, then rewrite this. So here, if I wanted to update my value, I would have written like temperature equals this, then it would have gotten overwritten. Otherwise, it's not overwritten. It's just different namespaces. Yeah, so that's the idea. I will skip this part. We are just trying similar thing here as well. Just remember there are different namespaces, and it doesn't get overwritten if you reuse the same name inside your function. But one good thing to know about functions when we are working with them is, well, we saw already these doc strings. Was it last week or the week before? This is one way of adding comments to your Python code. That you use these triple quotation marks, and inside it you can put comments. So this is particularly useful when it comes to Python functions. So it is a good habit when you're defining a function, inside it put a doc string explaining what you're doing in your code, in your function. So here you put a triple quotation mark and you write, this function converts temperature in kelvins to degrees Celsius. So whoever is using your code, looking at the Python function, they will know that, okay, this is a function that does this kind of task. So very often when you access libraries, they have functions and they have usually doc strings explaining, okay, this converts temperature in kelvins from kelvins to degrees Celsius. These are the parameters you need to provide. This is what it returns. It's a float. So this is just a comment telling you how this works. So let's try this. I will create a new cell here to try this out. And I'm going to copy this function. So I'm converting a function, I'm defining this function. And next thing I'm doing is help. And then use the name of kelvins to Celsius. Typo. So not only you have added comment, but also the comment is accessible to the user. So if you write a script, and we are going to look at that in the second part of the lesson today, and you share that script with someone and someone wants to know how this works, if they just write help with the name of your function, the same doc string you have put here is going to get printed out. So this is very useful. If you make a script that you're sharing with people or for yourself later on, you can access this doc string even if you're not looking at the code using help. Yeah, so this is a good habit to have. Now let's take a break. We have more stuff to cover today. So let's take a 10-minute break and continue at 10:30. Okay, we are all here, so maybe we can start. So before we continue with the core topics of the lecture today, let's take a look at AI and programming in Python. One thing that I should have told you earlier, but I guess you have figured out by now, are the buttons up here. I saw that when you were doing your exercises, there were some confusions. You were adding things to list, and every time you ran it, it just adds to the same list. So remember, when you're starting a Python session, you're working within the same memory. So if you want to start fresh, remember to restart the kernel. So it's just the thing I wanted to tell earlier. So what this does is just restarts Python. So you start fresh. So if you have a list in the memory, so the memory is wiped out, then you start running the code again. So if you have a list in the memory and you append and append all the time, it just gets longer. So you can restart the kernel and it wipes out the memory. This does the same thing, but it runs all the cells. So if you have a long program, you want to test it, it just runs through the whole code. But yeah, I guess many of you had figured this out by now. But yeah, let's take a quick look at AI and programming. Like I said in the first week, so large language models can do a great job. Like when we actually drafted the first version of this part was 2 years ago, so these things were still new. Now they do even better. So our policy is that, of course, now in this course is a very basic course. We are learning programming, so it's not good to overuse or use at all the large language models for this. But they can be very helpful in the long run. So if you continue doing programming, all of us use it to some extent, and it helps us a lot in, like, it reduces the amount of work and many repetitive tasks. We don't have to repeat many things because it does those things quite well. But we have to use them carefully. So the idea of these few minutes that I will talk about this is to show you the potentials and give you a bit of warning and mistakes they can take. They can make. So AI and programming, they perform very well. The example we have here is from ChatGPT, and it was written before, so now it might do things a bit differently, might be a bit smarter. We have new models released, and there are so many other large language models, some of which are specialized for programming, like even GitHub has its own. So, yeah, so they can be useful, AI and large language model. Here the example is from ChatGPT, and we have told you how we can use it, but you don't have to use it, and I'm sure most of you have an account, but it's not part of the lesson, so you don't need to do this. I'm just showing you how it works. You're familiar with this kind of user interface, that you have a prompt you write, and that's your main way of communicating with the model, and you tell the model what you want. For example, here we ran a few example prompts a couple of years ago, and now I'm going to show you what it gives me and how I should look at the code, like, critically, because it can make a lot of mistakes. So you should, especially if you're new to programming, you may not see the mistakes right away, but it does that. So what I was trying to say, I wrote to ChatGPT, write me a Python function that adds 2 numbers. And it did it perfectly. It's a very simple task. It can just do it very easily. It works fine, no problem with that. Then I asked, give me an example of using the output of this function in an F string, the thing that we do quite often in this class. So it just wrote me an F string like this that just gives you the output. So it works very nicely. I asked ChatGPT add inline comments to the code. This is something we often do. So it added comments. So from the comments I can see it's ChatGPT produced. One thing I didn't ask for, but it added, is this doc string. So I asked for inline comments, but it also added doc strings. Not exactly what I asked for, but why not? So it doesn't necessarily, it might overdo things or do things that you haven't specifically asked for. Then I asked ChatGPT to write me a Python function that converts degrees Fahrenheit to Celsius, very similar to what we have done many times today, and it created a neat function with a doc string. So, these large language models have memory, so because I had asked the model before to add inline comments, next time it's just adding comments. It knows I want to have comments. So that's something that is a potential, but also it can be risky if it remembers something from past and just pollutes your code with that idea from the past. So this also works. I skipped some parts, so we save time for other things that we have to do today, but it works nicely. So writing prompts is important. So if you end up using ChatGPT, which I don't encourage for this course at least, but if you use ChatGPT, just be careful with the prompts. So remember that it is smart, but it still is a computer. It's a machine. It's based on a statistical model. So you have to be very clear with the objective. So what do you exactly want? So if you add a bit of vagueness or leave it to the ChatGPT to assume things or come up with things, then that's where problems begin. And I tried to challenge ChatGPT here to see how it can handle those challenging situations when there is a bit of confusion. So I asked ChatGPT to write a function to convert Kelvin to Newton. And I did this in a new chat, so I didn't know that we are already talking about temperatures. So what it surprisingly did, it gave me just some weird thing that doesn't exist. So it just confused Newton as it works with forces and in physics with temperature. So what we have here, it doesn't make sense at all. Might be a bit smarter now, it's been 2 years, but if you don't add enough context, you might get weird outputs. And if you don't look at the code critically, you might just submit this as your assignment, and that would be bad. So yeah, so you have to add a bit of context. So a function to convert temperature in Kelvin to Celsius. So adding the word temperature gives a bit of context to ChatGPT or any large language model that you're using, so you might end up with better response. One thing that ChatGPT is quite good at, and many people use it, is for debugging the code. Especially if you are working with a large code and you get errors, sometimes it's a bit hard to decipher. Like now we are doing a small things, you can see where the error is coming from. But if you have hundreds of lines of code, it can be very useful with that. What else have we tried? Give me a Python function to convert a list of temperatures in degrees Celsius to Newton and print out the results. So you have to be like specific, a list of temperatures. Like, does it mean a list like as in Python? Should the input be a list or how? So you have to be specific with what you want. Another thing I tried was that I asked ChatGPT to create a Python function that classifies an input temperature to 5 classes. And this is what it gave me. So this is a very common mistake many of us can make. You do this, it looks good, it's doing the classification. But there are a few problems here. What problems do you notice? Well, first of all, I haven't given context. I'm vague. So it's just doing classification based on its own idea of temperatures. So if you want to do this, you should specify what should the classification be like. But other than that, what issues do you see in this code? And it works fine. If I run it, I don't get any errors. But it looks very bad. It has some issues. Do you see anything? One thing that is very weird, and I don't know how ChatGPT ended up doing this and why, is this. There are 2 functions defined there. It doesn't lead to any error, but it just did it. So one of them is totally useless. You just need one function, but it is a function inside another function, and one of them is just useless. So it just did that. And you run the code, it works fine, but whoever looks at your code knows that, okay, this is, no human would make such mistake, because it doesn't make any sense. So that's one mistake. Doesn't lead to an error, but it's just wrong. The other mistake is that I had asked for 5 classes. And what it did is that, okay, there are 5 classes here, but there is also an else statement, so it's actually 6 classes. So it's inaccurate. So if you have been given the assignment or the job to do something like this, and ChatGPT is actually returning 6 classes, so it's not exactly what you were instructed to do. So it can make such mistakes. So be careful with that. But anyway, it's a functional code, so it works, so you may not immediately notice that it's broken. Yeah, so the main point here was that it can do a lot. It can help you with programming, but it can also make mistakes. So be careful and read the output critically. Even if it doesn't cause an error, it might have weird issues like this. And also think about privacy. Now we are more aware of this, but a couple of years ago when we started talking about this, it was very topical. Just when you're putting things there, it's just there. We don't know what, especially with these companies, we don't know how they use it. So be careful with privacy matters, especially if you're working with the data and the data is sensitive. Don't just upload the data, assuming that it's safe there. Yeah, so conclusion, use it wisely if you have to. Just write good prompts. Lack of context is bad with large language models, so provide context. If you're doing conversions with temperatures, make it clear that, okay, we are talking about temperatures. If you have complex logic, don't just leave it to the large language model to figure it out. Just break down the logic for it so it knows what you want. Make sure you test and make sure that, so it is not just checking for errors, but make sure that it's actually correct code. But also security, especially in this case, it's not a problem, but imagine if you use a code that you're going to make a website on. It might have all kinds of security holes and issues. So if you are really creating a tool to host on the web, then make sure, if you use ChatGPT or something similar, make sure you go through the code very carefully, because you might have security issues. But yeah, this was a quick thing to just give you an idea of what you can expect from large language models in programming. If there are no questions from this or functions, then we can move on to the next part. And that is using script files. So let's open a new notebook, writing scripts. Okay, so the idea of scripts is that we make it very simple. When you're working, when you're developing things, you end up creating a lot of functions. And like you're solving a big task, it's your thesis, it's a project you're doing for a company. So it's easy to imagine that the code gets very long. So you will have many functions that do many things. So one problem is that your code gets very long. You have hundreds of lines, and it becomes very annoying to browse through lines. That's one thing. Second thing is that you may want to use these functions later on. So you have come up with a way to calculate a certain thing, and you want to use it again in some other project, in another exercise. So do you want to go back to those files and copy-paste everything? Well, that's one way to do it, but if you do this regularly, it's a bit annoying. So that's the idea of a script. So a script is essentially a separate Python file in which you just put your functions. It can be other things as well, like classes and stuff. But now we have worked with functions. So you just put your functions in a separate file without overcrowding your main file. And then you can import the functions from that. So that's the idea behind the scripts. Creating a new, clean, empty script file, putting some of your code there, and then you import it when you need. And it can be used from different codes you're writing. So that's the idea of it. So Python files end with the extension .py. And now we are going to create a new Python file and work with it. So let's try to do this now. So in Jupyter Notebook, you can create a new file in a number of ways. But let's do it this way: file, new, and then you can choose a format. So I go with Python file. So remember that your Python files should be .py. So your script should be a Python file. So here you can write your Python code. That's what we're going to do now. Yeah, so you can see you created a new file. Until you save it, it's not saved. So this is temporary. It's not saved yet. So when you save it, then it asks you for a name. But we are going to do that shortly. And make sure that the file has appeared there. It looks a bit different. It has the Python logo. It's a Python file. So let's start by adding a function. So similar to what we have done a lot this morning. So it's a function that converts Celsius to Fahrenheit. I'm going to paste it here. So I have already one function inside my script. Then I'm going to save it. When you save it for the first time, it's going to prompt you and ask for a name. So I'm going to use this name, temp_converter, as the name of my file. So remember not to change the extension. So it's a .py file. It's a Python file. So remember to save it. So it's an easy mistake to make. That you just put something there without saving the file, so it's not actually accessible. If you try to import it, you get an error. If you later change your mind, you want to change the file's name, of course you can just rename the file. You can just right-click on it and just go to rename. But for now, I'm happy with this name, temp_converter.py. So you rarely make a script file just for 2 lines of code for a simple function. So probably you have a bunch of functions that you want to access. So I'm going to also copy and paste these functions from what we did this morning. So let's also paste these here. And make sure when you're pasting, the indentations are not messed up. It looks fine in my case now. Okay, so remember to save, otherwise you cannot import them because they don't exist on the drive. So the idea is that, okay, I don't have to write this every time I use something. I have these functions, I have saved them in a Python file, and I'm going to reuse them whenever I want. Okay, so now this is how you can create scripts. When you're loading them, the key thing is that you make sure you're in the right place. So those of you who are familiar with Python, with Linux, you know how to check the directory of where you are. Here using IPython, you can also use this magic command to see the contents of the directory in which you are located. So let's run this. I can see that there are a bunch of files here. And most important, so I can see I'm in the right directory. So my Python is running in the same directory. And most importantly, I can see this file, temp_converter.py. So this means that it's looking in the right place. So I can import my file. So remember, if your Python is in some other space where the .py file is not located, then when you try to import it, of course, tells you that it's not there. Then you have to navigate to the right place. That's not the case for us, but if you needed to navigate similarly, again, those who are using Linux are familiar with this, you can just see the change directory to the right place where you are. But I guess for most of us, this should be correct. You see your .py file. Yeah, so now that we are in the So we did this already. We know we are in the right place, so we don't have to change anything. Now we continue with importing our script. So remember, you just pasted some of your codes from this morning here. And now I'm going to reuse them without pasting them here, like bringing them to my workspace. So this is how you import. Remember, the name of the file was temp_converter. So you say from, and this is the name of the file. And from that file, what do you want to import? So here you can name the function that you want to import. So remember, we had one function that was called Celsius to Fahrenheit. So I'm saying from temp converter script, import that function called Celsius to Fahrenheit. And if I run it, I don't get any error, which means that it found the file correctly and the function existed. If you had any typos, if you were in the wrong directory, you would have gotten an error that what you were trying to import doesn't exist or cannot be found. So now the function is there. So you can use it the same way as we have used it this morning. So let's just try it out. So I'm going to write a print with an F string, as usual. And I'm going to say the freezing point of water in Fahrenheit is what I'm doing, I'm just calculating it using the function. So Celsius underscore to Fahrenheit. And it's for freezing point, so it's 0. There. So as you can see, we don't have the function here. I didn't run the function here. It was all stored in that .py file, but I imported it and I can use it. So imagine years of doing Python programming. You have a lot of good functions you can reuse. You just keep them in script files and reuse them. So that's very handy. So there are other ways of importing functions. For example, if you have multiple functions in the same script, you can use it this way. So from my script, in our case is from temp converter, import, you can list functions that you want to import and separate them by comma. So in this case, I could have written from my script or from temp converter, import this, comma this, comma that. So if you need all of them, just don't fill up your memory. So if you don't need them, don't import them. But if you need them, just you can do it in one line. You don't have to do it separately. Of course, you can do it separately as well. Another thing that you're going to see a lot in Python is giving nicknames to scripts. And this is how you do it. So I have a script called temp converter, the one we just created together. And it's a long name. So if I want to access a function from it, every time I have to write temp underscore converter dot something. So it's very common in Python to give it a short name. And this is how you do it. You put as. So import temp converter as TC. It's a short name. You can give anything. TC is short for temp converter. So very often when we work with libraries, we are going to talk about libraries after this, there are like habits. So those of you who will be doing GIS, we will work a lot with GeoPandas, and it's very often called GPD, because GeoPandas is long. So import GeoPandas as GPD. From next week, we will be working with a library called Pandas, and the short name for it is, it's a habit. It doesn't have to be like that. It's PD. So import Pandas as PD. Then you don't have to type so much. It's just shorter. So let's see how this saves us a bit of typing. So let's see. I'm going to redo what I did earlier. I'm actually going to copy and paste this. So here I would have written temp converter. But because I made the name shorter, I can just put TC. So from TC, it's importing this Celsius to Fahrenheit. Okay. Something that many people who are new to Python might get confused is that when you're importing, if you explicitly import the name of the function, then you can access the name. But if you just import the library, here I'm not specifically, I'm not explicitly accessing a library, a function. I'm just importing that whole script. In those cases, you have to tell, okay, this function is from this script. This is why I added this. Because here I didn't import function names. I just import the whole script. And in your work, you do it a lot. You might import 10 libraries in your work. So you have to specify, okay, this function I'm trying to access is part of Pandas, is part of temp converter, is part of GeoPandas. And to make that shorter, we give these nicknames. So if you have to repeat this for those other functions we have here, then we can try it for one more. So I'm just going to copy and paste this and change a few things. So absolute 0 in Celsius is, and from TC I have a function Kelvins to Celsius. And I'm going to try it for temp Kelvin 0. Yeah, so with these short names, it's a bit less typing. Okay, so let's move on to the next section, creating a temperature calculator. So the function above had only one parameter, but now we will add another function that with multiple parameters. So let's just make it a bit more sophisticated. Yeah, so the function is very similar to what we have done. You just have the temperature you get, and you can ask what to convert it to. So it takes the temperature in Kelvin, but the person can choose whether to convert it to Celsius or Fahrenheit. And it, of course, returns a value, the converted temperature. To make it more proper, like I said, it's a good idea to add doc strings. So here we have added doc string. So there's nothing new happening here. That's why I'm browsing this quickly. So it's the same function with a bit of doc string. Let's just copy this from here and take it to our script file. Control C. So I have a new function here. I will paste it. Remember to save the file, otherwise you will get an error. So now I have a new function that I can use, temp calculator. Okay, so now that you have a new function here, you have to import it. So let's import it again. So I'm going to import Yeah, so one good habit here is that because we are redoing things, now we imported the library, we changed the library. To make sure we have a clean memory space, it's a good idea to restart our kernel, what I taught you earlier. So let's restart the kernel to wipe out all the imports. So, okay, so now that we have a clear space, memory space, let's import the script again. So it was called temp converter. I'm going to give it the short name TC. I have a typo here. Okay, so now it's accessible to me. So remember that I told you it's a good habit to have doc strings, so help. So now you see what I meant, because now the function is in a different file, so it's not just in front of you. Of course, you can go check, but why not just use help to see how the function works? So I can just use help, and I'm getting help for the function temp calculator. And it just prints out the doc string that I asked for. So especially if you're defining functions and storing them in a separate script file, it's a good idea to add the doc string so you can see, okay, now without looking at the code, I know that, okay, these are the inputs, this is what I have to provide. Now let's try our function. So I want to try it with temperature Kelvin 30. So let's create a new variable called temperature C. And I'm going to access the function that I just created. It was called temp calculator. And from the help, I already know which parameters I have to provide. So I know that I have to provide a temperature in Kelvin. And I already have that stored in a variable, temp Kelvin. And I need to provide another variable, another parameter, and that was convert to. What do you want to convert it to? And it takes C or F. Do you want to convert it to Celsius or Fahrenheit? So now the calculation must be done, but to make sure it works properly, I'm going to print an F string. So my temp Kelvin is this is the output, temperature in Celsius. I don't want to have so many decimals, so I will just limit it to 2 decimals. Remember, we did this a lot a couple of weeks ago. Degrees Celsius. I have a typo. Okay. What?
It's the temperature.
Here, yeah. Yeah. So, an example why it's good not to repeat your code, because typos and these things can happen. Yeah, so this is very handy, and I'm sure you will end up using this a lot in your work. You will have these nice scripts that you will be using over and over and just enrich them over time. There's certain fields you're working a lot in, GIS or your own fields, if you're coming from geology, then you will have these scripts that you can revisit over and over. So, do we know already how to work a script? Yeah? Yeah, so scripts are good, and yeah, they keep your code clean, and you can reuse them. Just remember to add documentation, comments, doc strings, so they stay as reusable as possible. So that was the script. We still have one small part, and that is modules, which is related topic. We have seen them before briefly, but we haven't really opened it up. So what are modules? Like, some people call them modules in Python world. I guess module is the more official word, but many people also call them libraries. So they're essentially scripts that are developed by other people. So you are just using pandas. Next week we are using pandas. It's a very popular library for data sciences. So it's developed by a group of people somewhere. They have published the library, and you can now use them. So essentially it's the same thing. This is a script, but someone has developed it, and they're usually longer. It's some complicated task they're solving. So that's what modules are. You can download them, get them from people, or very often you can, if they're official or more mainstream modules, you can just install them through Python and have access to them. So that's the idea behind modules. Yeah, so one of the best things about Python is that it has a very rich ecosystem of libraries. So if you want to do a certain kind of visualization, if you want to, like, I don't know, create a Gantt chart in Python, I have never tested this, but I'm sure if you Google, there might be a library somewhere that you can use to create that kind of chart. If you want to do a certain kind of calculation, the odds are that if you Google, you might find some similar work. So that's a very good thing. If you can just reuse a lot of the work that is done by other people. So it has a very rich ecosystem, and you might hear the words module, package, or library. All of them are used, but referring to the same concept. So they are a bunch of .py files, very similar to what we have created, and they provide you with classes, with methods, with functions that you can just use in your work. And we saw this briefly, and it's very similar to what we have just done with our own script. If you want to import a library, as I say, it's just a script. So you can just import, put the name. Some libraries are built in, or they come with the Python package, like math is already there. I haven't installed it. Some of them you have to, if they're more specialized, you have to install them. So as I said, this library is already installed, but one trick, you don't have to do it for this course because we have installed everything that you might possibly need for completing this course. But if from Jupyter Notebook, if you want to install a library that is missing, for example, in your final project, you want to get ambitious and do something different. For example, through pip, you can install a new library. So for example, you can say pip install GeoPanda. So those of you who have done Python before, this is familiar for them. It's just you can access it from Jupyter Notebook, you can access pip or conda or with exclamation mark. So pip install. So if you need a library later on, you can install it this way. But since we are running on CSC Notebook, every time you do this, start a new session, it's wiped out. So you have to install it over and over. But yeah, normally when you're doing this, you're running on your own computer, you install the packages that you might need. But yeah, now we imported paths. Let's make sure we run the cell. And from math, I want to use square root function, which we saw already in week 1. Yeah. So this is how you import libraries. Easy. Remember that some functions are built in. So with built-in functions like print that we use all the time, you don't need to import anything. It's just in the memory already when you run Python. So with built-in functions, you don't need to import anything. One thing that we saw with our scripts is renaming or giving a short name. The same thing applies to libraries. So if I'm working the library math a lot and I'm lazy to type these 4 letters every time, I can give it a short name, import math as M. Then if I'm accessing a function inside math, I can just put M dot instead of math dot. And like I mentioned, there are habits, so don't go with weird names that you wouldn't remember later what you mean by them. So I'm going to import math as M, and from that I can use SQRT. So it lowers the typing load a bit. And if I check the type of M, the nickname I've used for my Python, it knows that it's a module. It's a nickname for the module you just imported. But like I said, there are very often habits. So from next week, we will work with this library called pandas. And very often it's imported as PD. So you will see that in people's codes. Importing a single function. So sometimes, like I said, libraries can be big. They can take a lot of memory. Nowadays, with our computers, it's not so much trouble. But as a good habit, it's good not to import everything unless you really need them. If you're doing a lot of math, then it's wise to import math library. But if you just want a SQRT and that's it, why would you import everything? So very often you see people just importing one function. So from math, they import, for example, a SQRT. So this doesn't take so much of your memory. You just import that one function. And another benefit of that is that because you have explicitly imported the function, I don't need to write math.sqrt. It's enough you just write sqrt because you have explicitly imported that function. Yeah, so one thing that can happen is that, well, with nicknames and also the name of libraries, because libraries are not something central, like Python hasn't developed all these libraries. People just develop and share with the world. So they might end up with like conflicts in the names. So imagine if in your work you have used a variable name called M, and then you import math as M. You are overwriting M. So when you are giving nicknames, or if you're importing a library, make sure there is no conflicts. Like the person who has written this script might have used a name for their function that is the same name as what you have used in a variable. And so there can be conflicts with names. Just be careful. If something weird happens, then this could be one of the reasons. Very often bigger libraries that we will be working with might have sub-libraries or sub-modules. So this is a huge library, like matplotlib is something we will be working on, I guess, in the last week for visualization. So we make charts, and later those who do GIS, they can produce maps with the same library. So it has a sub-module called pyplot that gives us some additional functionalities. So you will see us doing this a lot later on. So from matplotlib.pyplot, I'm importing this sub-library from matplot. So matplotlib is the bigger one, pyplot is under it, and I'm giving it a short name, PLT, which is quite common. So sometimes bigger modules have sub-modules, and you can specifically import the sub-module, not the whole thing if you don't need it. Like matplotlib is quite large, so it can be heavy. So let's just run this. Using this sub-module, we created this kind of chart. This is something we will be working with later on. But this PLT we imported allowed us to use this plot function that makes this kind of plot for us. So checking available functions and modules. Well, if it's your own script, you can just open the file and see, okay, I have these things available. But sometimes these are just bigger modules, and it would be handy to see a list of things that are available. So you can do that using dir, short for directory, put the name of the library, and it gives you a list of things. Like these are classes and functions that are available to you. So here it's not a full list because math is a very big library. You can see it just stopped at some point. But yeah. So from Python itself, you can access a list of functions that are available in the library. But more often what people do is just Google. They go to the documentation pages of the library. They see how it works. That's best. But if you don't have internet, you're on a different planet with no internet access and just a computer with Python installed, then you can just use this to see what you have available. Another thing you can do in Jupyter Notebooks, so this only works in Jupyter Notebook, is that you can browse available modules. So when you're typing for math, for example, then if you press the tab key, it's going to suggest you a number of functions. So with S, it's suggesting you some functions that start with S or have S somewhere in them. So if you're unsure how the function is exactly named, or you just want to save time on typing, then you can just try tab. And this works only for Jupyter Notebook. So if you use this in, I don't know, in other environment, you may not get the same thing. And one thing we saw earlier is that you can just use help to get some information about the function. And like we saw, these are just doc strings that the developers have added to their functions. And if you type help, you get the doc string out. So it's assigned as a simple function with a bit of information. Yeah, sometimes you don't know what modules are available to you, what modules are installed already. Then you can try help modules and you get a list of libraries that are installed. So you can try it here to see what we have installed for you for this course. So modules are great one of the best things about Python, but there are a few things you should be careful with, things to avoid. So in Python, you can import this way, and it used to be common, at least 10 years ago. Many people did that, but it's not good. So from a library, you can import, instead of putting the name of the function, you can put a wildcard. You can put this asterisk sign. And what this does, it imports all the libraries in that function, all the functions in that library. So there are a few bad things about this. One is that it takes a lot of memory. Other thing is that there is a very high chance of conflicts with names, because you're importing everything that they have used in math. So imagine some of the words might be just same as your script. So that's bad. That's a bad habit. You will see it in some places, but it's not recommended anymore. But it works. So from pandas, you can import asterisks. It brings all the functions. Poor names when renaming an import. Same rule as giving good name to your variables applies here. Go with the standard. So pandas is often PD. GeoPandas is GPD. Go with the standard. Or if you are just being creative, go with something that is intuitive. And there are some rules how to work with the scripts. Let's quickly look at this GCP 4, Good Coding Practices 4. So I won't go through all the details, but we have talked a lot about importance of documenting your work, and you can do it in a number of ways. Like we have talked that in Jupyter Notebook, it's good to write markdown cells. It's good to put inline comments. It's good to put doc strings. This is particularly important when you're working with scripts, because these are separate files, so they're not right in front of you, so it's easy to forget what they do. So when you're writing a script like the one we just wrote here, this one doesn't have comments. If you do this, add as much comments as possible to make sure it's understandable later. Make the scripts tend to get very long. If you have one script that you add all your functions, imagine after years of working in a certain field, you might have a script with hundreds of functions. So just keep them clean. For example, put the spaces in between functions so it doesn't look crowded. So technically, these spaces are not needed, but it just looks nicer if I have a bit of a space between them. So spacing can be good, make it more readable, but of course don't overdo it. And doc strings, as I said, doc strings are very good and important for functions, but also it's a good idea to add doc strings at the beginning of your script file. So just to start here that, okay, so this is a script developed by me, you put your name. If you're sharing it with the world, you can put licensing information, you can write that, okay, whoever is seeing this file can use it for their own research, not for commercial purpose. But any information, you might want to put your email, I know if someone wants to contact you regarding the script. So doc strings are important. You put date, when did you last update this script. So it's good to start your script with a doc string with a bit of information about what you might have. And like I said, if you get libraries from other sources, they often start with this. So they have some information about licensing, for example. Another thing that we are not going to worry about in this course, but it's a good practice, is to start with a shebang, and that is something like this. So it makes it easier for Python if you're accessing the file directly from Python, not from, for example, JupyterLab, then it's easier for Python to locate the script. But we are not going to use it just as extra information here. Yeah. So I know it was a lot of information today, but you will get to see how this works in practice in your exercise. So we have exercise 4. Again, we have auto-grading. Hopefully it works well for this exercise as well. We know that there have been some small issues, and we will fix them for next year. But yeah, we will have auto-grading, accept the classroom assignment as usual, and work in pairs. And there are some hints how to do this, but we will be working with the scripts and functions like we learned today. yeah, that was all. If you have any questions, now is a good time to ask. If not, we can wrap it up here and continue next week with pandas. Yeah, see you next week.